Okay, conjugate salt equilibrium part 2. And as I said, to do these, for sure do 75, 76. You can do the odd ones, and then do number 1 and 2 calculation. These problems, you should know how to do them. I was looking over them again, and yeah, it's pretty much a review. We already talked about it in an earlier lesson, about the lesson on acid strength and base strength and all that. I guess one thing that I didn't highlight so much, or I did talk about it, is that if you're comparing two acids, let's just say you're comparing two acids, the one that has the higher Ka number is a stronger acid. Okay, now if you're a stronger acid, that means your Kb value will be lower. You'll be a weaker base. Okay, I'm gonna show you that. I'll show it to you a little bit mathematically as well. Okay, so here we go. First, I was thinking there is one thing that's going to be on the assignment that, let me see if I got my worksheet here. I was thinking I'll go over a little bit. If you were to look back, the worksheet for bases, on the back of it, there were some questions that asked to predict. It says predict is number 4. I'm going to do a little bit of that right now because at some point, you need to know how to do it. And I kind of already, let me see, where's my eraser? Oh boy, the eraser. Well, I got a little cloth I can use if not. All right. So, I know I told you this, that in the worksheet for bases, on the back, it was number 4. I said, don't do that yet. It was in the wrong place. Well, I'm doing it now. I'm going to talk about it for you. And you could be able to do it too. I'll just do some of them. I don't know. We'll see how many. I might do most of them. All right, the first one says this. RBC2H3O2. It's kind of like what I showed you a moment ago, actually. The last video. When you put this in water, should the pH be acidic, basic, or neutral? This is a solution. Should it be acidic, basic, or neutral? So what you do is you look at the positive and the negative ion. So this has acetate and rubidium. Rubidium, the metal ions, they're not going to do anything. Okay, the only thing you need to be looking at is the ion the conjugate of a weak acid or the conjugate of a weak base. Okay, so the weak bases are NH3 and then whatever CH NH2, CX HY NH2. So their conjugate means you have to have NH4 plus, or you have to have CH NH3 plus. For that matter, if you were to see anything CH in with an H on it, and if you saw a plus, you know that that's a conjugate of a base. Take the H off, and that's the base. That's the conjugate base. That's the I'm sorry, that's the conjugate, and that will be the base. Okay. Well, I don't want to confuse you there. These are the main two to look at for NH3 and H2. And it's conjugate NH4 plus. So if you see an NH4 plus conjugate or an NH3 plus conjugate, you know that that's something that can affect the acidity or basicity of water. Okay. Now, the weak acids, I'll put any A minus in HA, any A minus except for strong acids, and you know that. Okay, so those are the two rules, the two main things to be on the lookout for. So, acetate, yeah, that comes from weak acid, so it will affect water. And so what will happen is C2H3O2 negative, just take that ion, plus water, and I already showed you this, and it will actually be equilibrium. Gives you HC2H3O2 plus, if you take an H off of water, you're left with OH negative. Okay? The next one, KClO4 negative. All right, now first, negative, KClO4, potassium perchlorate. Okay, first of all, the metal ions aren't going to do anything. I told you about that, okay? ClO4, now, that is a conjugate base, ClO4 negative. So what is it's a base. What is its conjugate acid? Would be HClO4, and that's a strong acid. That means for strong acids, they do not affect water. It will not undergo hydrolysis. It will not, hydrolysis means splitting water. And you really are. Acetate breaks the H off of water to make acetic acid, and then the OH is left over. It split the water, hydrolysis, breaking up water. Okay, ClO4 will not do that because it comes from a strong acid, so it will not affect. All right. The next one says KClO3. Now, KClO3. Now that's a weak acid. Okay, HClO3. That's the anion from a weak acid. So again, the potassium won't do anything, but that will. And so what will happen is, here's the equation, ClO3 negative, same thing, HOH gives you HClO3 and OH negative. So it will be basic. Maybe I didn't mention it on the last one. That one will be basic. That one will be neutral, KClO4. KClO3 will also be basic. I think you get the idea. Oh, well, here's a good one on D. And I know I keep looking. It's probably on the floor. Where did I drop my eraser? I always looking for things around here. Okay. Is that it? No. Oh well. This little cloth I use to wipe off the dry erase board, but I can use it here too. It doesn't matter. Okay. Here's an interesting one. NH4ClO3. Now, first of all, let's look at the two ions, and I think you can already notice something right off. NH4 plus, the big one, that's a conjugate of a weak base. So yes, it will affect. NH4 plus will affect it. Well, ClO3 is also a conjugate, and it will affect it. But now, if I wrote the two equations, you'd see them. You already had the ClO3. I erased it. But ClO3 causes water to be basic. Remember? ClO3 ends up reacting with water to make HClO3 and OH negative. So it makes it basic. But NH4 plus makes it acidic. Okay, so NH4 plus, this is one I showed you in the last video, plus water. Well, that's just going to add, like an acid, it's going to add, take off the H to give you H3O plus, and you're left with NH3. So that means acidic. Well, here's the deal. This makes it acidic. This makes it basic. So acid plus base is pretty much neutral. Now, this is an interesting thing about AP. If they're asking you to estimate it by estimation without any numbers, then you would guess it's going to be neutral. And you can show the two equations. They would want you to show both of them. This one, and then, well, I'll write it again, and the one that you saw on the other paper. This makes it acidic. This chemical, chlorate, makes it basic, OH negative, and together they will cancel out to be neutral. You'd expect that. But what you really have to do is look at the Ka value. This will have a Ka value. This will have a Kb value because it's a basic reaction. And you look at those two numbers, and the one that is higher, like whichever one is higher, that means that the solution should be acidic or basic. So it might really be a little bit acidic or basic, but it's going to be really close. So in generalizing, you're probably safe to just assume it's going to be neutral. But if they give you numbers to work with, then think about that as well. All right, and I'll just do one more of these for you. There's a lot of good ones in here. Well, how about, well, I want to do one that's, okay, actually all the way to E, and you haven't seen this much before, and that's a good thing because this can happen as well. Now, this is from your textbook, NaNH2. Now, that's another polyatomic ion, all right, NaNH2. And that would be like the amide or amide group. I guess amide is what we call it. So you know that sodium is always plus 1, so the NH2 must be negative 1. Okay, can you see that NH2, it looks like it is, yeah, it's a conjugate, and it will affect water. Okay, so here's what's going to happen, though, but watch how it affects it. NH2 is going to be minus 1. So actually, if I take the H off, you get NH3 and OH negative. It actually is basic. So that's kind of a weird one. That's kind of a strange one. I guess they kind of do that in there to throw you off. You're thinking, oh, it'll be it'll react as a base, but it won't. Look at the charge. If it's -1, it does that. Now, if this had been +1, and it's not, had it been +1, then it won't take an H away. It would give an H to that. It would be H3O. It would be acidic. But it's -1 there for sure. I don't think you're going to see that, but oh well. So I would show you that little bit. Okay. And I can't believe I didn't give you one with just NH4. Like, just say NH4Cl. Remember I showed you the NH4 a moment ago, but if you had NH4Cl, that will make the water acidic. Because this will do nothing, but that will give an H to the H2O, making H3O. The reaction I showed you just a moment ago on letter D that canceled. So I'm saying, like, on letter D, NH4ClO3, if it had just been NH4Cl, well then Cl, since it comes from a strong acid, it will have no effect. You can ignore Cl, but only NH4 would predominate and it will be acidic. Okay, so that's how you do those little things. All the other stuff, even on this base homework page, it has these things on here about which is a stronger base, arrange, weaker to higher and all that. I talked about that in an earlier video, and you should be able to do it. You should know how to do all of that. I'm not going to check that, but you'll get the answer keys to it, and even on the new worksheet. Okay, so now let's finally get to the math. So here we go. And I will try. How long has this video been so far? I can't really see. I will try to make this be not too long, I hope. Conjugate acid and conjugate base. Now, on the AP exams, I told you every year they're going to ask equilibrium. It could be an acid, Ka, a base equilibrium, Kb. It could be gases, Kp or Kc. It could be gases with molarity or gases with pressure. Or it could be Ksp, which we'll do more of that soon as well. There's another type it could be. It could be a Ka conjugate acid equilibrium or a Kb conjugate base equilibrium. I call it that. So really two more. Now, if that were to happen, it has happened before. I know I can think at least twice, but it's pretty rare. But it usually happens as part of another problem. But I think there was at least 1 year that this was the main problem. So let me show you how it works. I'm going to go, let's see. We're going to skip all the way over to F. I just realized that on letter E, indicate whether these are basic. Or I could have done those examples instead of the other ones I just did for you. Oh, well, it's the same deal, though. And the other stuff, arranging in order, I can do them in class, but I pretty much did those for you as well, I believe, in the past. All right, F. Calculate the pH of a 0.30 molar sodium fluoride solution and refer to the table 14.2 of these notes. Table 14. Oh, okay. That'll be back to fine. Okay, I'll explain what you mean. Here's how it usually works. They tell you sodium. This is going to be sodium fluoride is going to be doing a reaction. I'm going to go all the way back to 14.2. Where is that? Okay. Back in your notes, there was a table somewhere that told you Ka's of acids. I just found it. It's right. It actually is in section 14.2. You expect that 14.2. Look at hydrofluoric acid HF, and it says 7.2 10 to the -4. So Ka for HF equals 7.2 times 10 to the -4. I'm going to show you something about that in a moment. Now, if they were to put this on AP, what they're going to do, they're probably going to ask you first to write the equation, or they might themselves. So it'd be like, okay, if you have 0.30 molar NaF, write the equation that will indicate the equilibrium system that will result. Okay, so what's going to happen is sodium is not going to affect the pH, but F will, and it's going to be fluoride. I think I did this one for you already. And water. Now I can make it H2O or HOH. I'll write HOH. Now this is the conjugate of a weak acid, HF. They even if they give you the Ka for HF, that kind of gives it away a little bit as well. Oh, it's going to make HF. So F is going to pull the H, and then you also get OH negative left over. It's a basic. All right, this is a conjugate base equilibrium problem. Now, you'll do the ice box as we always do. 0.30 molar of F. Now, you would watch this carefully, 0.30 molar NaF, and you know that there's only one of these. If for some reason 0.30 molar AlF3, well, then that means that actually you're going to have 0.30 molar aluminum fluoride means 0.90 molar F negative. You see there's three of them, of the F negatives that react here when it splits up. But that wasn't the case, that wasn't the case, it wasn't the case. So you're okay, 1 to 1. 0.30, these are 0, minus X, plus X, plus X. 0.30 minus X, X, and X for your icebox. Now, here's a big difference. I see my eraser now. I found my eraser. Now I gotta find my calculator. Oh, got it. Okay, here's an interesting thing. The Ka, and I told you this already in a video, but the Ka for any acid times the K, all right, if you have a weak acid Ka, if you multiply it times the Kb of its conjugate, this times the conjugate will always equal 1 times 10 to the negative 14. Just like the water, OH, H plus times OH negative molarity gives you that. Well, this is also true as well. So, if I know the Ka of HF is 7.2, 10 to the negative 4, then the Kb of F negative will equal, okay, this divided by that. So just do the algebra. The Kb of F negative equals, I like to put the little F negative below it just because that way I know. This equation is on the formula sheet of AP. Ka times Kb equals that. But I like to label what do they tell me? Oh, Ka of HF is this. So that means the Kb will have to be the conjugate of that. That has to be F negative. That helps me a lot to not mix it up. So the Kb of F, I mean, you can leave it off if it gets too messy looking. But the Kb for F negative, the Kb will be this divided by that. So 1 times 10 to the negative 14 divided by 7.2, 10 to the negative 4, which is 1.39, no, 1.4. 1.4, 10 to the negative 11. Okay, I'm going to have to erase this because my space is limited here. So Kb is 1.4, 10 to the negative 11 for F negative. I just found that right here. Okay, now, how can I use that? Now it becomes easy, just like you do in any other icebox problem. Oh, but write your Kb expression. HF times OH over F negative only. Remember, water didn't go in it. Kb, make sure you use the Kb, not the Ka. 1.4, 10 to the negative 11 equals, sorry, just gotta get out of the way here. I'm going to block it. Okay, HF is X at equilibrium. H is X at equilibrium. And F is 0.30 minus X at equilibrium. So now, assume X is negligible, so everything becomes the same as any other problem. And, okay, so, being negligible, be careful with that, because I've seen as I've been grading some papers and quizzes, sometimes people say, assume it's negligible, and they ignore the 30 and not the, you only ignore the minus or the plus X term. The plus X or minus X or plus 2X or minus 3X or whatever it is, you don't take away the number. You need the number there. Okay, so then this is algebra here. So 0.30 times 1.4, 10 to the negative 11 equals that. Get the square root. 2 times 10 to the negative 6. Let me double check it. 1.4, 10 to the negative 11 times 0.30. Then get the square root of that. 2.0, 10 to the negative 6 equals X. Very small concentration. Molar equals X. Now X, what is X? It is your OH negative. Aha! Be careful, be careful. Because like I said, they always seem to ask on the AP, find the pH. They don't say find the POH, even though that's what you would find first. But find the pH. So first we'll find the POH. We learned lesson the other day, but I learned my lesson about it's going to be easier to find POH first, as long as you know how to do that process. So POH, I'll do it right here. POH is negative log of the OH, 2.0, 10 to the negative 6. So 5.2 sig figs, 70. So the pH will be 14 minus 5.70 equals pH 8.30. And of course, that certainly is basic. All right, let's just see. How am I doing here on my time? All right, almost got it. All right, so there's one more. That's how you would do this conjugate salt. And I'll go quick, but I'll do the other conjugate salt as well. So you have one of each type. So the conjugate base, the conjugate of a weak acid is a basic. The conjugate of weak base is acidic. Calculate the pH of a 0.10 molar NH4Cl. 0.10 molar NH4Cl. Calculate pH. Here we go. So, again, chloride came from a strong acid. You know that's not the one that will react with it. It'll be this one, NH4 plus and water. I can make it HOH, or I'll just make it H2O, because I know on this side we're going to put H3O plus and NH3. Okay. Now, the Kb for NH3 is equal to 1.8 10 to the negative 5. Now, if you realize that you have that kind of situation here, it's going to be a conjugate, then what you could do, you could just go on right now and find out, well, what's the Ka for NH4 plus? The conjugate of NH3 is a base. So, the Ka times Kb is 1 times 10 to the negative 14. Since the Kb of NH3 will be here, I'll label it, that's going to have to be the Ka of NH4 plus. So, Ka NH4 plus, if you want to write it, times Kb of NH3, 1.8 10 to the negative 5. That came from a chart, by the way, but I knew that. You would be given that number. Now, just divide that out. So 1 times 10 to the 14 negative, divided by 1.8 10 to the negative 5. 5.6 10 to the negative 10. All right, equals 5.6 10 to the negative 10. The Ka for NH4 plus. Well, I'm just for myself. I'm just trying to write that down. That's what I'm going to use. Okay. Now, I'll do the icebox super fast, but it's the same deal. So here's my equation. Ice box. 0.10 NH4Cl, and these are going to be 0 minus X. Don't you love it? It's all one. It's all like sorry. All right. X. It's all like 1, 1, 1. All 1 to 1 to 1 to 1 ratios. All the acids and bases that you'll have to see on AP that you'll get to see will be doing that way. All right. So this is a Ka this time is equal to H3O plus times NH3 over NH4 plus, and that Ka is 5.6 10 to the negative 10 is equal to X. Seems like it's always the same problem, isn't it? Over 0.10 minus X. So assume X is negligible. And I keep forgetting to do my little negligible. Is approximately X squared over 0.10. And so, let's just do that math. 5.6, 10 to the negative 10, times 0.10, and get the square root. And it's 7.5, 10 to the negative 6 is X. And I can double check my math real quick here. If I ever made a mistake on the math, at least you kind of get the idea. Hopefully that you know how to do it anyway. 7.5 10 to the negative 6, yeah. And what is x? We're trying to find the pH. X is, this time x is H3O. That makes it even better. So, pH, negative log of H3O plus. It's negative log of H plus or H3O plus. You can put either one for the symbol, remember? And you see that these conjugates are really small pHs. But hey, so they don't affect it as much as an acid or a base itself, but the conjugates do affect the pH. Okay, so that'll be log negative is 5.12 will be your pH in the acid range for sure. Okay, so just remember, I've told you many times to the problems. So if you want to do right now, number 1 and 2 are the calculations you'll do. And then you might want to do those first or whatever. And then these are the parts are like the non-math. I think you could probably do all of that, but I didn't want to feel like it's too long. So if you at least do these two, the odd ones and those math, that might take you like 20, some of you might take 20 minutes or so. That's enough. But make sure you at some point you look at those. Okay, you should know them. They could all be multiple choice kind of questions and stuff I could ask you. All right, I will see you later. Goodbye, guys.